Anyways, today is day 3 of Think, and I am here with the esteemed John Walicki. Why don't you tell us a little bit about yourself, John?
Sure. Great to be here, Colin. So my name is John Walicki. Today I'm an Internet of Things Developer Advocate, but earlier in my IBM career, I started at IBM Research in Yorktown Heights, and I was part of the Watson IT organization. I supported all the research scientists. They were coming out of universities, and they wanted to run Unix, and so I did a whole bunch of work with BSD, with Agora, with MIT Athena, and I parlayed that open Unix type of mentality into this thing called Linux.
Yep.
And so in the late 90s, I started to run Linux on my desktop. And that
was the year of the Linux desktop.
We were
20
almost
years
close.
running.
Yeah, we're still working on it. We're going to get there. We are going to get there. So.
I run Linux on my desktop
Perfect,
as
as do I. But what was interesting at the time was the fact that it was disruptive and it was all open, and we really built a great community around breaking down barriers.
Okay.
And so after supporting the research scientists with their work, I moved over from IBM Research over to IBM IT, where I led the Linux desktop initiatives for IBM for about 2 decades.
Perfect.
And we beat down barriers throughout that time. I introduced Firefox and Mozilla to IBM in 2005. We were stuck in this IE6, had really stagnated. That early internet hadn't been evolving as rapidly. We saw the introduction of JavaScript as a great way to open up HTML and make HTML much more rich and dynamic. And IE6 was not really the right platform for JavaScript, let me tell you. So we introduced Firefox into IBM, and we were working through all the inhibitors to really adopting open standards. Open standards and open source has really carried the day over the last 2 or 3 decades. And you see that with Linux. It's pervasive today. It runs the cloud, it runs containers, it runs arguably on the vast majority of Android smartphones. It saved the mainframe, right? All of our Linux on Z workloads have really been a core part of bringing that whole mainframe model back into play.
So here's a question for you. Whenever you're talking to those who are not familiar with open source and don't know a whole lot about it and think it sounds kind of dangerous because everybody can go and review the code and anybody can submit code, how do you tackle that?
So being open is first as a mentality. You have to think open, right? You have to be willing to make your code better because someone else's idea. Give away your idea and then be open to other people's ideas and let that code evolve, right? Let people bring their passion to it. I am the first one to have an opinion until someone else's opinion is better, and then I adopt theirs because, and yeah, that's a mindset. If you get really stuck in this cement tier, you're not really going to be successful in open source. You have to be willing to evolve with where the code base is going, with where the community wants to take it, and so embrace that, and you'd be surprised what people can do to help you make your code base better. Whether it's yours or a community's, it sort of starts out, I've done both, right? You start a community and you sort of feel like it's John's. And then after a while, it's not really mine anymore. It's
you give it out. It's everybody else's.
Yes.
It's everybody's.
And then I'm willing to walk away a little bit from it because I know it's running. Someone else has got it. Right? I've passed a baton to some other passionate people.
And then on to the next thing.
And on to the next thing. Or like small contributions too. I'm the first one to say, oh, this piece of software is awesome. And then a couple of minutes later, I'm like, oh, this sucks. This little feature here, I can make it better. And here's a small patch. That little small patch is sort of meaningless, but I felt good that, hey, I gave it back. And I think my opinion was I made it better because first it was awesome. Then I found something that was kind of rough on the edges, and maybe I sanded it off a bunch. And so that give and take in open source is really what has propelled it.
Cool. I mean, my entire career has been in open source. I thought when I got hired by IBM, I was going to come in and work on some proprietary secret sauce.
No.
And I came in, they're like, hey, OpenStack. And I was like, yes, please,
Sure.
let me work on OpenStack. That'd be great. And here I am today.
So we can do both. As an enterprise, we can be open, and we can bring that open technology to solve business problems. And with the right level of support and the right level of expertise as core contributors to a technology, our enterprise customers want to find, one, trusted sources, and two, they want to be able to come to us with more ideas, because when we understand their workloads, we can help make that open source technology better, scalable, right? You always start off with, hey, it works on my machine. And then more workloads come, and then you realize, well, it can't work on just John's machine. It has to work on all sorts of things.
Yep.
And so making it scalable is hard, because no one wakes up and says, I'm going to make my app scalable today. You really have to think hard about how to make
Really?
an app.
Because that's my first thought in the morning. I'm kidding.
But OpenStack has been working on that. How do you take this distributed set of workloads and parcel it out, make it elastic?
Yeah, definitely. So why don't you tell us a little bit about
Toys.
toys.
So I brought some toys. So I'm an IoT guy.
Yeah.
And they run Linux too, right? Which is brilliant. Sort of why I follow my Linux passions. So I brought a TJBot, and TJBot's cute little guy. He's got an arm and an LED and a microphone and a speaker and a camera is in his eye. And it's a great way to make a Raspberry Pi come to life, because at its core, it's just a Raspberry Pi with Raspbian, and you can take the LED and the arm servo and the microphone and speaker and tie those to Watson services and talk to it, have a conversation, have it do things in the real world, like wave its arm and blink a light.
Yeah, that's always, waving the arm always gets everybody. They love it. Everybody loves it.
Great fun, and a great way to introduce people to Watson Cognitive Services. So it was I think an exercise in trying to be cute, but then using the technology to showcase some of our Watson services.
Cool. Why don't you tell me about that giant TJBot that I saw?
Wow.
That thing was cool.
So this guy was designed by some colleagues at IBM Research, and 3D printed or get a laser cut. You can do it's a cardboard, but a couple of maybe 100 yards to my right, there is a giant TJBot, which is about 8 foot tall and 8 foot wide. And you put this guy next to it, and it's like a couple of thousand scale size bigger. Quite a monster.
Yes.
But very clever and a great photo op.
I would love it if they got like a couple hundred of them and lined them up like they're all, like bowing down to the giant one.
The giant one.
That'd be such a great picture. I would love that.
So I run a set of TJBot workshops, because this is a great workshop thing.
Yeah.
When it's plugged in, mine has a wake word. So you say, hey, Watson.
That's a perfect 2-hour workshop.
Yes,
thing. Yeah.
right. So you sort of set it up and you learn about Watson. And so I taught it how to listen for a wake word, and runs local, doesn't send any data to the cloud. It's just waiting, uses a technology called Snowboy.
Yep.
Kit AI you train it with a model, and it listens for hey Watson.
Okay.
So I built 10 of them. I had a workshop with 10, and they were all sort of sitting on the desk here. And during my intro talk, I said, hey Watson. And they all woke up at the same time, and they say, how can I help you? So it was like one of these,
You're like, yes, my minions.
Minions.
It's perfect.
Very fun.
So what about this thing right here?
So more practical.
Yes.
Is blockchain and IoT asset tracking. So one of the use cases that are really quite useful is being able to track your stuff in the real world. So the combination of where the device is, the environmental conditions that it's experiencing, and the time. So those three elements, where, when, and what. If you send that up to the cloud, and in the case of a food safety or medical supplies or cargo ships or whatever container you want to be tracking that has some environmental conditions to it, you can write that to a blockchain.
Yep.
And now you can look back, and so was it the farmer or the truck or the distribution and the processing center or the port or maybe the retail or the distributor, where did that particular container experience environmental conditions, extreme temperatures, vibration, whatever sensor you might want to connect to this.
Yep.
So that's a perfect use case for blockchain.
Absolutely.
Multiple participants in a network, the insurers care, the Walmarts of the world care.
Yep.
And so I said, all right, let's build one,
Yeah.
right? Because it's a great use case, but show me the money. Show me how to build one. So I bought myself, and you could do this with a lot of different boards. So this one happens to be a particle electron.
Okay.
And so it does, it talks to cell towers,
Yeah.
and so it's 3G. It is, so if I know a cell tower, and I know a cell tower, and I know a cell tower, and I know the signal strengths between each of them, it becomes a math algorithm to figure out geometry to figure out your signal strength and locations. Those cell towers don't move. Now your accuracy is not 100%. You're not going to get hit by a precision missile.
Yeah.
But
Which might be a good thing.
yeah, but you probably get hit by a 2,000-pound bomb. So we have a great opportunity to actually show this to customers and say, how could you build one?
Yeah.
Well, so I just took some off-the-shelf parts.
Cool.
I've got a temperature and a vibration accelerometer connected to it, and every couple of minutes it wakes up, bleeps its location to the cloud. It stores, I use Node-RED. I store it in a Hyperledger Fabric. I built a model over in Composer.
You said that is deployed on IBM's container service, correct?
That's right. I actually follow the instructions that the Hyperledger IBM Cloud team has published, and it's set up using Kubernetes, a Hyperledger Fabric, Composer, and a REST APIs.
Yep.
So once I saw the REST APIs, I'm like, perfect, I know what to do with this.
Yep.
And so I wrote a bunch of puts and gets to write the data from the board, and once I got the data to the cloud, over to the Hyperledger. And then I was able to play it back.
Perfect.
In a map.
Yeah.
And so I just draw a map in a browser window, bunch of CSS, and make it look pretty. And you can
Maybe
actually
some JavaScript drawing libraries in those.
I pull in a world map and moves the thing in a real world. I drop little pins everywhere that environmental conditions might have exceeded whatever threshold I set.
Yeah, another nor'easter hitting New York, New Jersey.
Yeah, so it's coming. I left my wife and kids at home, and they were not so happy that I'm here in Las Vegas. So if they're watching, they're probably giving me a little bit of a stink eye.
Yeah. Well, John, I think we gotta wrap it up. But thank you so much for coming by. You have a code pattern coming out for this thing right
yeah.
here?
There's going to be a IBM Code pattern that talks about IoT asset tracking with blockchain. So
Awesome.
check it out.
Perfect. Thank you very much, John.
All right. Thanks, Colin.